Good morning, physical science. This is part one of the rates of chemical reactions, looking at our slides and our class notes. If we were in school together here, which I wish we were, this is exactly what we would be doing today. So I wanted to start off with my good buddy, Chemistry Cat. And Chemistry Cat says, I was going to tell a joke to my students, but I was afraid there would be no reaction. You get it? Now, Chemistry Cat also goes on to say, told a joke to some noble gases. They didn't react. Get it? Noble gas? Stable octet? Okay. So you can kind of get an idea. We're going to be talking about the rate of chemical reactions. And rate just means how often. Now, we've talked about this already, but in physical science, when we talk about chemistry, we talk about chemical reactions are dependent upon how often and with how much energy particles collide. Remember what we said. In order for chemical reactions to occur, particles must collide. So we know that already. But what we didn't mention is they have to collide with enough energy to cause the reaction to occur. And this is known as activation energy. If not enough activation energy is present, then the collision is not going to be energized enough and nothing's going to happen. No reaction will occur. We can see here where we have two reactants. They collided, but they did not have enough activation energy. And so nothing happened. No products were produced. Down here, we have a successful collision and we have products that form. So it's all about this energy of collision, which we call activation energy. Here's another quick joke, because sometimes reactions can go too slow or too fast. And here's one flask to the other. Seriously, dude, I think you're overreacting. And you can kind of see here that this reaction apparently is going a little bit too fast. And sometimes we need to make sure that our reactions are kept at a stable rate. Now, there are several factors that affect the rate of reaction, and that's what we're going to talk about this morning. As you already know, but let's recap. Rates of reaction are dependent upon how much energy the particles have to begin with. In other words, is there enough activation energy? If not, then we're going to have to adjust. The second point is how often they collide. What's the frequency of their collisions? Now, there are four factors that we're going to discuss that affect the rate of a reaction. The first one is concentration of particles. And concentration means how many are there, how packed are they, how close together are they. Here we have a few molecules. In this scenario, there are a few collisions, so the rate of reaction will be quite low. If I added more of each reactant, then we have many molecules or particles. There are many more collisions, and the rate of reaction is therefore much greater. So concentration, and sometimes we lump this in with pressure too. If we increase the pressure, if we squeeze them together, we make them more concentrated, then they're going to react more often as well. Now, this is not exactly what I mean when I say concentration. Here we have chemistry dude, and he's thinking to himself, if I could just increase my concentration, maybe this reaction would go faster. That's not exactly the factor of concentration that we're talking about. The second way of affecting reaction rates is to increase temperature. We just talked about increasing concentration and pressure. But if you increase temperature, well, if the temperature increases, the rate of reaction increases, because increasing the temperature increases the kinetic energy of the particles. And this causes the collision rate to increase, and therefore the rate of reaction increases. Surface area. Here we have scenario A. You can see the red particles are all surrounding this large chunk of reactant